Welcome to my YouTube channel. Today we will learn first chapter of Icse 10th standard. That chapter is force. So just a brief introduction I will give about the force. So we'll start. After that we will start the topic. Already we have a study. What is force? Simple definition. Force is kind of push or pull which either changes or tends to change shape, size and position of the body, or simply dimension of the body. That is one of the very basic definition of force. Now second, sometimes we say force is force is a product of mass and acceleration. But apart from this, in this topic, we have to study what happens with the body when force is applied on the body. Like whatever force will when force will apply on the body, so what will be happen with the body, that we have to discuss in this topic. So let us start. We have force. Topic is our force. And A part is there. Today I am going to discuss A part. Moment of force and equilibrium. A rigid body, when acted upon by a force, can have two kind of motion. If we are applying the force on any body, there will be two kind of motion. Simple we can say, if we are applying the force on this body, then this body will move linearly. Linearly means straight line. And if any body is there whose axis of rotation is fixed and we are applying the force on it, so what will happen? It will start to rotate as we apply the force. So when a force is applied on a body, there may be two changes. Either body will possess translational motion, that is linear motion or a straight line motion, and secondly the body can rotate, means there will be rotational motion. That is the effect of force on the body. So I have mentioned over here, I have mentioned linear, two kind of motions may be possible over here, linear or translational motion. Linear or translational motion. So as you can see, when the force is applied on this ball, stationary ball, then this is the direction of motion. This direction means it is the straight line motion. So force, due to force, the body can perform translational, linear or straight line motion. Now second, again when the force is applied on this body, like when axis is fixed, like simple way we can say door. As we apply the force on the door, axis of rotation is fixed through the hinges, so that can rotate about that axis. Like this, if we are going to fix it's one of the axis and we will apply the force on it, so it will start to rotate. So force can produce linear motion as well as rotational motion. So we are discussing about the second part, that is the rotational motion. Like this pivot point, it means that is the axis. Axis is fixed, so as we apply the force on it, the body will start to rotate like this. So it is turning effect of force, means when force is applied on any body whose axis is fixed, so that will start to rotate. So it is the turning effect of force. Next part is moment of a force or torque, that is the turning effect. So factors affecting the turning of body, factors affecting the turning of body. So like we will say, if this body is rotating, so what are the possible factors? So it can rotate faster as we apply the force on it, maximum force, so more rotation will be there. And second thing is that perpendicular distance from axis of rotation. Simple way. One example I will give over here. Suppose this is the fixed point, or we can say it is the axis of rotation. Axis of rotation. It is the axis of rotation. And a door is here. And axis of rotation is fixed one. A door is here. Now we have the several places. One handle is over here at point A, another handle is at point B. Now we know that if we apply the force on point A, then easily we can open or close the door. But if we are applying the force on point B, then more force we have to apply. So one factor for the turning effect of the body is force, and second factor maybe as this distance is more, so less force we have to apply, and as this distance is less, so more forces we have to apply. So what we can say about it? Okay, this is the perpendicular distance from axis of rotation of B, and this is the perpendicular distance from axis of rotation of point of action A. So simple way, as we are observing, as distance is more, we have to apply less force. So second point is the perpendicular distance from axis of rotation. So two factors are there. First is the magnitude of force applied. More force, more rotation. And second, the perpendicular distance of the line of action of the force from axis of rotation or pivoted point. So simply we can say, instead of this one, we can say simply it is the perpendicular distance from axis of rotation. So it will depend, turning effect of the body will depend on two factors. One is the force and second is the perpendicular distance from axis of rotation. And best example I can say, opening a door. Example for this is the opening the door. In that case, we know as we apply the force, door will start to rotate, and how much force we have to apply for opening the door, that will depend two factors. One is the force and second is the perpendicular distance from axis of rotation. Means axis of rotation and the point at which handle is fixed. So these all are the factors affecting the turning of a body. Now definition is there. Moment of force. The moment of force is equal to the product of magnitude of the force and perpendicular distance of the line of action of force from the axis of rotation. So this is a definition. We can say this is the definition. Same thing we can say about the door. Suppose this is the axis of the door. No, this is the axis of the door at which door is rotating, and we are applying the force on it. So what is the moment of force in this case? This is the force we are applying, and this is the axis of rotation. So this is the perpendicular distance. So simple way, moment of force about the axis passing through the point O is equals to force into perpendicular distance of force from point O. So moment of force is represented by tau, that is torque. Tau we can write tau, notation is tau, is force and perpendicular distance from axis of rotation. Product of force and perpendicular distance from axis of rotation. Just this is the concept behind the moment of force. I will again say, for remembering, to keep in mind what is the moment of force, you have to remember the example of the door. Again, door have one axis which is fixed, and handle. At the handle you apply the force. So what is moment of force? That is the product of applied force and perpendicular distance from axis of rotation, and the point of application of force. Okay. Now there are the two type of moments. As moment is applied on the body start to rotate. That already we said. And we have to remember that there is the possibility of two type of moments. One is clockwise moment, another is anti-clockwise moment. Now let us see clockwise moment. We will say, I will write about it as, I will take it clockwise moment. Clockwise moment. In clockwise moment, what will be our observation? In clockwise moment, I can say this will move like this. This is the clockwise moment. And in clockwise moment, we take it as negative. We take it as negative. We will write its negative value. It is taken as negative. And in anti-clockwise moment, we take anti-clockwise moment. It will be taken as positive. Now thing is that why we have to take it positive and negative? For there is the reason, and reason is on behalf of right hand screw rule. So I will write direction is given on behalf of right hand screw rule. Direction, sorry, symbol, not direction, we will say. This positive and negative is given on behalf of right hand screw rule. So it is given by right hand screw rule. Now what is right hand screw rule? Let us see, if we are going to rotate any screw, we are going to fix any screw in the wall, then we have to rotate it clockwise. Now clockwise, as we apply the force in clockwise, then its direction is inward, and inward is taken as negative. And when we rotate it anti-clockwise, then it comes outward, and outward is taken as positive. Fine. Next term is unit of moment of force. So again, unit of moment of force. We have written moment of force definition. By definition, we have written the formula. Moment of force is defined as the product of force and perpendicular distance from axis of rotation, as already I have told. So unit will be definitely, unit of force is Newton, and unit of distance, perpendicular distance or simply distance, unit of distance is what? It is meter. So unit of moment of force will be Newton meter. Now next term is couple. As we talk about couple, so what comes in our mind first? What is couple? Anything, like we say couple of shoes. One is of left leg, another is of right leg. So that is said to be couple. One is positive and negative charges. That may say couple of charge. So one is positive, another is negative. So that kind of, like we will say two forces. If two forces are acting on a body but in opposite direction, that will form a couple. That may form a couple. That is said to be a couple. So what is couple in fact? Like we say we applying the two forces on a body. One is to this direction, another to this direction. So forces are this and this, and forces must be equal in magnitude, and definitely they should be at distance d. D or S or R, distance we can denote by any letter. So what is couple? Couple is defined as the product of one of the force, because these two forces are equal in magnitude but they are acting in opposite directions. So product of one force and perpendicular distance between two forces. Right? This is the perpendicular distance between two forces. That is the couple. We will define it later on. But one thing I will say, when a couple is applied on any body, the body start to rotate. Turning effect. We are going to study about the turning effect. Let us see some practical examples. If we have to rotate this one, then what we have to do? Possible case is this one. We are going to apply the two forces on this body, one from this side, another from this side, like this. So it is what? It will give us turning effect. So we are applying equal forces to this direction as well as this direction. So body will start to rotate like this, and forces should not be applied at the same point. Both the forces should not apply at the same point because they will cancel to each other. So what is the condition? If two forces are acting, two equal and opposite forces are acting at two different points on the body, then body will start to rotate, and that arrangement is called the couple. Equal and opposite, equal forces but in opposite directions. Lot of examples we can take regarding this one. Suppose we have to open the neck of this bottle. So what we have to do? We have to apply the force. And how we are applying the force to open or close? Suppose we want to open it. So we are applying two forces. One thumb is, I am taking it back in direction, and finger ahead like this. So we are applying the couple on it. As well as for the closing it also, we apply the couple. One force is to this direction, another force is to this direction. These all are the best ever examples of what? Couple. Some diagram I have drawn over here. These are the diagrams you can see. First is opening or closing a tap water. So for opening it, again what we do? We apply the couple. One force to this direction, another force to this direction, and at two different points, not at the same point. So this is one of the example. Another bottle, that's live example I've already given. I think so that is clear. And whatever diagram I have drawn over here, the same diagram is here. So when two forces, this force and this force, are acting at two different points, and this is the distance between two forces, so moment of force, in this case we can write moment of force that will be again represented by torque, tau. Greek letter is tau. So torque is one of the force, that is F, into perpendicular distance between two forces, that is AB. So this is the torque, and AB is D. So therefore tau is equals to one of the force into perpendicular distance. Now this becomes the formula. Again, that's whatever things I have mentioned, that in definition format is here. Moment of couple or torque, both the terms are same. Moment of couple or torque or simply couple, it is either force, one of the force, I am telling one of the force, or either force, one of the force, into perpendicular distance between two forces, or that is also called as couple arm or moment arm. That again I will say, this distance is called as couple arm or moment arm. Now equilibrium of bodies. Next term is equilibrium of bodies. So when two bodies are said to be in equilibrium, like I'm here, one force somebody is applying from this direction and same force another person is applying from this direction, so I will not move anywhere. Then you can say that I am in equilibrium. I'm in equilibrium because I'm not moving either to this direction or either to this direction. It means the two forces are acting at me. They are equal in magnitude but exact opposite in direction, so they cancel to each other. They cancel to each other, and then again the body is at rest or in same state of motion. So that body is said to be in equilibrium. We can see the definition part. When a number of forces acting on a body, produces no change in its state of rest, if it is at rest, it is at rest, or of linear or rotational motion, the body is said to be in equilibrium. It may be applicable for the rotational motion also. If any body is rotating and number of forces acting on that one and still it is rotating, it means number of applied forces on the body is in equilibrium. That body will be said in equilibrium. Now, kinds of equilibrium. What are the types of equilibrium? Two types of equilibriums are here. Kinds of equilibrium. One is static, another is dynamic. Static, I will say. Static, meaning of static is at rest. Static means at rest. And dynamic means whatever position. If it is rotating, then it is continuously in rotational motion. It is performing the rotational motion continuously. Then that will be said as dynamic. Like for dynamic, I will give one example. Like if any aeroplane is in air, that is in air. So that is in air only, because gravity is acting, it should fall down. Upthrust is there due to which it is in upward direction, but still it is moving at a certain height. So regarding height, I can say that is in equilibrium. So this is an example of dynamic equilibrium. Let us see the definition parts. Static equilibrium. Static equilibrium. What is the static equilibrium? When a body remains in the state of rest under the influence of several forces, the body is in static equilibrium. As I said, I am seated over here. Number of forces are acting at me. Somebody is applying the force to this direction, somebody is to this direction, somebody is to this direction, somebody to this direction, and still I am at rest. It means total sum of the forces acting at me will be 0. Then the body is said to be in equilibrium. So simple way we can say, if any body is at equilibrium, sum of all the forces acting on the body will be 0. That is. So once again, I will discuss the definition of static equilibrium. When a body remains in the state of rest under the influence of several forces, the body is in static equilibrium. Or we can say sum of all the forces acting on the body will be 0. Resultant force will be 0. Next is dynamic equilibrium. Dynamic equilibrium. What is the dynamic equilibrium? When a body remains in the same state of motion, that may be either translational or rotational, under the influence of several forces, the body is said to be in dynamic equilibrium. And I have given the already example of aeroplane. That is same as the example of dynamic equilibrium. Now, conditions for the equilibrium. What are the conditions for the equilibrium? Conditions. There are two conditions. One is already I have mentioned, that the resultant of all the forces acting on the body should be 0. What? First factor, sum of all the forces. So simple way I can write it. Summation of sum of, that is also called as sum of all the forces on the body is 0. And second condition, the algebraic sum of moments. Again, what is the moment? Moment is defined as the product of force and perpendicular distance between two forces. So algebraic sum of moments of all the forces acting on the body about the point of the rotation should be 0. So sum of all the moments is 0. So I will write it simple way. Summation means sum of moments. Sum of moments will be 0, or we can write it summation of r into f is again 0, because r into f, r is the perpendicular distance between two forces. Here I can draw the diagram to remember you people, like one force is applying to this direction, another force is to this direction, and this is the distance between two forces. These are the 2 points A and B. Here is force F as well as here is F. So it will be R into F. That summation of R into F will be 0. So I think so it is clear. So we have two conditions for the equilibrium. One is summation of all the forces is 0, and second is summation of all the moments is 0. Sometimes we call it this, we can remember it like sum of all the clockwise moment will be same as the sum of all the anti-clockwise moment. So clockwise moment always must be equals to anti-clockwise moment. That is simply the principle of equilibrium that we will see further. Next term is principle of moments. Principle of moments. What is the principle of moments? As I told, okay, clockwise moment must be equals to anti-clockwise moments. If any number of forces acting any body and the body is at equilibrium, and in that case if clockwise moment is equals to anti-clockwise moment, then we will say that body is in equilibrium. So according to principle of moments, if the algebraic sum of moments of all the forces acting on the body about the axis of rotation is 0, what? Sum of all the moments means clockwise moment plus anti-clockwise moment, that sum is 0. And remember, clockwise moment is taken as negative, anti-clockwise moment is taken as positive. According to direction, we will decide the signs of the moments, whether it is positive or whether it is negative. So further, according to principle of moments, in equilibrium, sum of the anti-clockwise moments is equals to sum of the clockwise moment. This is very important part. Actually, most of the numerical we will solve on behalf of this part. Now, next part is this is what we can say, one of the conclusion I have written. For solving numericals, we have to keep in mind some very important points I have given over here. For calculation of moments, weight of the body always will exist at the center, or we can say center of the body. Its total weight will exist at the center. Like I will ask to you people where its weight will exist. So definitely where it will be balanced, that definitely will be its center of gravity, or that is the center. So at center its weight will exist. So if any body is given and it is going to be asked to us where its weight will exist, so definitely we will say it's at center. Next is all the distances will be measured from the fulcrum. fulcrum or balancing point, we will say. Balancing point. Like I can say, if any body has balanced at this one, so and in this case I'm telling we have attached two weights, one from this side, another from this side. So if we attach the weight from this side, so it want to move to this direction, so this will be moment, direction of moment will be this one, and this weight will keep it in this direction. So one is clockwise, another is anti-clockwise, and it may be. So the sum of, if the sum of moment of this side will be sum of moment of this side, so the body will be in equilibrium. And for equilibrium we have said already, clockwise moment must be equals to anti-clockwise moment. So second point, this at which point it has balanced, that is called the fulcrum or pivoted point. I have pivoted it at this point. At this point it has been pivoted at this point, or we can say this finger is the pivoted point, or it is the fulcrum for this body. So you have to remember these 2 points for the numericals. These 2 points are very, very important. Now this is the end of the chapter, means every points I have included in this video, and there is the request to all of you, to everyone, please subscribe, like, share my channel. Thanks to everyone for watching this video. We will meet in next video with the numericals of the fourth topic. Thanks. Thank you everyone.